a 600-pound force, as you can see here in the right, this one here, and we are to resolve it into its components. Okay, as you can see, we have here a u-axis and we have a v-axis. Okay, not the common x-axis and y-axis, but rather it is u-axis and v-axis. So we are to resolve this 600 pound into the v-axis and the u-axis, which means we are to find the f sub u and the f sub v. Okay, now if we analyze this force, okay, it will, or if we simplify this figure, it will look like this one. Okay, so from this figure, this is our target. We have to project this 600 pound here in this axis and in here. Okay, so in order to do that, we have to draw a parallel, or we will apply the parallelogram law, which if we do that, so we will make a parallel line which is parallel here to the u-axis. Okay, and that would be like this. Okay, so as you can see here, this line is parallel here to the u-axis, while this line here is parallel to this v-axis. Okay, this is our given force, which is 600 pounds. Take note also, class, that the unit here used is British Engineering, or the FPS. So we will be using pound, not the Newton, as our unit of force. Okay, so there, earlier our value of the angle is 30 degrees, which is, as you can see here, 30 degrees with respect to the u-axis, and we have here the 30 degrees also with respect to this structure here. Okay, so let us find the other angle, going back to the figure there. So since this part right here, class, this one, this is parallel here, so they will have the same angle. Okay, it will have the same angle, as well as here, this angle here, this 30 degrees is the same angle here. Okay, and this angle here, 30 degrees, is the same angle here. Can you follow? Now, again, our target is the value of the f sub u, or the component here at the u-axis, and the component here, which is f sub p. So let us just isolate a triangle out of this parallel to apply the triangle law, which will then look like this. There. Okay, why is it that this f sub p, going back, why is it that this f sub p here is already here? Okay, let us go back here. As you can see, this part, this f sub p is just parallel to this one. Okay, they are just equal, so therefore you can put here f sub p, and then we will just isolate this part right here. Okay, and the result is then this, as you can see. Okay, so we have here the 600 pound, we have the f sub p that is our unknown, and f sub u as our unknown too. Okay, so now that we have the working triangle, let us start solving it. Let us first define the given. So the only given there, class, is the 600 pound force. okay, the 600-pound force as well as their thetas. And what we are required is the magnitude of the um, component at v-axis, which is the FV. Take note, I have placed the bar sign to indicate that it is a magnitude only, as well as the magnitude of the force in the u-axis. Okay, so in order, class, to solve for this, okay, let us first have the f sub p. So going back to the figure there, so the f sub p is right here, this one, okay. So since our target is the side of a triangle and we are given here only one side, which is 600 pound, okay, and we have lots of angles here. We have 30 degrees, we have 120, we have 30, another 30 degrees. So what do you think? What kind of principle can we apply? Okay, again, our target is side. We have also one side and we have lots of angles. So is it the law of cosines or the law of sines? We will apply the law of sines. Why not law of cosines, ma'am? Why can I not use the law of cosines? Because, class, in law of cosines, you need to have two given sides, okay, and one angle, a minimum of one angle. But as you can see, we only have one side, and our unknown is another side. So therefore, where should we find the other side? Because it's still unknown, which is the f sub u. So we cannot use the law of cosines, but rather we will use the law of sine, which is this. As you can see, since this 600 pound is given, so we can have it here. This is our unknown, or this, or vice versa. And then we have lots of angle here, which is here. Okay, so we can use this law of sines. Okay, now substituting, I will make side A as our unknown, which is the f sub b there, and our side B as our 600 pound. So recall, the angle to be used is the opposite to that side. So in this case, class, f sub b, the opposite angle is 30 degrees. That's why this is sine 30 here. Well, this 600 pound, the opposite angle is also 30 here. That's why this is 30 degrees. Okay, now cross multiplying, we'll have this one. And since our target is f sub b, we will divide both sides of the equation by sine 30. And using your calculator, okay, encode these values. Therefore, the value of the f sub b is 600 pound. Okay, it's because, as you can see here, anyways, you don't have to use calculator. It's because, as you can see, you can directly cancel this out. Because sine 30, take note, they are just product here at the numerator, so you can simply cancel the sine 30. So this is the value of the v component of your given force. Okay? Now, how about for the u component? Okay, so the u component is right here, class. This one. Right here. So, this same, we will use the law of sines. Okay? So, in this case, we will make our side A as our unknown, which is the f sub u, while the given side 600 pound will be our side B. Okay, so in this case, class, the f sub u is having an angle which is 120 degrees. That's the angle that is opposite to it. Okay, so that's why 120, sine 120 here. The same with 600, so the same sine 30. Now, cross multiplying, we have there. So, the same, we will divide both sides of the equation by sine 30 to look like this. And using your calculator, encoding the values, we'll have 1039.23 pounds. Okay, that's the answer for our U component.